Hello everyone. Today we'll be solving the numerical on antenna radiation pattern for array antenna. Okay. The given question here is obtain radiation pattern of an end-fire array of 4 isotropic point sources with half wavelength separation. I'm underlining the important words here. Okay. So first of all, we are supposed to write what is psi equal to. Psi is dr cos phi plus delta. Delta is the phase difference. You should be knowing what is psi. Psi is a phase angle between the electric field that has been radiated by the isotropic point sources. dr is the radial distance and dr is given by 2 pi d by lambda. So this d is equals to what for this case? Half wavelength lambda by 2. That implies dr equal to 2 pi lambda by 2 divided by lambda. All these things gets cancelled. So what remains is pi. What about delta? Read the question again. It says end fire array. What does it mean? It means phi should be maximum. Okay, the maximum lobe is either at 0 or pi. Okay, so if you just do that, I'll write the equation for obtaining the angle at which we get the maximum. That will be n psi equal to plus or minus 2k pi. Let me take k equal to 0. For this case, n is equal to 4. 4 into psi will be pi cos phi m plus delta is equals to plus or minus 2k pi. For the first case, I'm taking k equal to 0. So 2k pi becomes 0. So what remains? Pi cos phi m plus delta equal to 0. So delta will be cos 0. So either at 0 I'll have main loop or at pi. So when I take phi equal to 0, cos 0 is 1. So delta will be minus pi. If I take phi m as pi, it will be minus pi. Delta will be just plus pi. Okay. So now I'll rewrite the equation. Psi is equal to initially what we had written dr cos phi plus delta. So it came down to pi cos phi plus pi. I will write like this. So this is psi. Now we have obtained maximum. The second one to obtain is the direction where I have side lobes. What is the equation? Sine of n psi by 2 is equals to 1. Okay, let me write these expression. So to know the angle where I have maximum, you are supposed to use this equation. First one, to obtain side lobes, let me always use this equation, sine of n psi by 2 equal to 1. And finally, I need to have nulls. Okay, so sine of n psi by 2 equal to 0. Using all of this, we will obtain the lobes, side lobes, nulls, and then we will write the radiation pattern. So in this particular case, n equal to 4. So sine inverse of 1 is what? Please be careful. You are supposed to write 2k plus 1 into pi by 2. Sine inverse of 1 is pi by 2. It can be, if I give k equal to 1, 3 pi by 2, 5 pi by 2. Okay, so be careful with that. N is equal to 4. 4 by 2 is 2. So I will directly write 2 into pi cos phi plus pi equal to plus or minus 2k plus 1 pi by 2. You can bring 2 here, you can take out pi here and then cancel it out. So I'll directly write the equation cos phi plus 1 equal to plus or minus 2k plus 1 divided by 4. So cos phi will be plus or minus 2k plus 1 by 4 minus 1. Okay, so this is the equation for you. Now what you have to do, give k equal to 0, 1, 2, 3 till you get the values. Okay, you get the values for 5. So since we are finding side loops everywhere, let me write the subscript. Yes. Okay, so we have the equation cos phi s equal to plus or minus 2k plus 1 by 4 minus 1. So for the first case, let me give k equal to 0. So cos phi s1, let me write it as, okay, s naught, let me write. K equal to 0. So plus or minus 1 by 4 minus 1. You consider if you give minus 1 by 4, minus 1 by 4 minus 1 will be minus 1.25. You will not get in value, any value for 5 because cos value, it will be from minus 1 to plus 1 itself. Okay, so what I'll do now, I'll take plus 1 by 4 here. Cos phi s0 equal to plus 1 by 4 minus 1 will be minus 3 by 4. Let me use my calci to find for which angle I'll get minus 3 by 4. By the way, I have kept my calci in degree mode. 138.59. Okay. Similar way, you can obtain for k equal to 1, k equal to 2. Let me do that. So similar way, if you can find for k equal to 2, I'm getting it around 75.52. K equal to 3, I'm getting it as 41.4. What is the next step to do? Next step is to find nulls. Okay, how do you find nulls? I have already written the equation before. So null is what? Where you have no radiation at all. So sine of n psi by 2 equal to 0. When do I have equal to 0? N psi by 2 equal to plus or minus k pi. Okay. So anytime, whether sine pi, sine 2 pi, 3 pi, whatever it is, it will be 0, right? So n equal to 4, 4 psi by 2. Again, I have 2 here. Pi cos phi, since it is null, I will write small n here. Plus pi equal to plus or minus k pi. You can cancel out pi here. So cos phi n plus 1 is equals to plus or minus 1 by 2. Okay. So now what I'll do? Cos phi n, sorry, it is k by 2. Cos phi n equal to plus or minus k by 2 minus 1. Okay. Again, here same process. You are supposed to take k equal to 1, 2, 3, 4 like that till you get the value for phi n. Okay. But thing is, you see here, if you give k equal to 0, cos phi n will be minus 1, which will be pi. That is not a valid answer. Why? Because already we know maximum is in the direction of pi. So what I'll do, I'll start taking the value from k equal to 1. Okay. Let me find the answers. Okay, so when I try to find the nulls, I'm getting it around 120, 90, and then 60. Okay, when I tried finding again for alpha, sorry, k equal to 4, I was getting it around pi only. So I'm just erasing it. So now what we will do, we will just list out all these values and then try to write the radiation pattern. Now we have to write that. So let me mark maximum side lobe null direction. So always better to start from 0. Pardon me for not writing a straight line. Okay. Let me write 180 and then minus 90 or 270. Let me write. Okay. Then always I prefer to write from nulls. So I'll write nulls. So first null we got was for 120. So 120 is somewhere here near to 180. So I'll write here 120 and then 120 minus 120. Similar way, let me write for 60. Here minus 60. Okay, minus 60 or 270 plus 30, 300, I guess. Okay, you can consider that. Then what do I have? So better I'll write here minus 90 only. Next, let me write for side lobes. All these are done. Nulls are done. Let me write the side lobes. Let me try to change the color of my pen. Okay, side lobe, where do I have? I have starting from 41.4. I'll write here 41.4. It's not 41.4, but let's consider. And then one more I have at 75.52. Then I have at 104.47, somewhere here. And then I have one more at 138.59. Since everything ended up with cos, I can write the same to the other side as well. Okay, the blue color what you see are side lobes. But where do I have maximum? 0 and pi. Always remember, how do you write the radiation pattern? Always main lobe is associated with, if this is the main lobe, it should end at first nulls. Okay, so these are called first null. This particular point is called first null. So now if you see in our radiation pattern, whatever we started writing here, 41.4 and minus 41.4 are coming in between the main lobe direction and the first null direction. So what are we going to do? We are going to ignore them. We are going to write our main lobe here like this. The main direction is in 0 and at 180, and it has to touch the first null. Okay. Next, what should I do? I'm supposed to write the side lobe, and then we have the null at 90 degree here. So 75.52 is a side lobe. I'll write a lobe which is smaller in amplitude compared to the main lobe. Similar way, I'll write here as well. Be careful. The lobe should touch the nulls at the bottom. Okay. So I will write here as well. Better to be symmetrical, always works. So this is the end fire array pattern with n equal to 4 and d is equal to lambda by 2. Okay, so this is how you do it. Now let me just explain one particular condition with this. Okay, see what we had done. End fire array means I knew that they are maximum is at 0 or 180 degree. If I had given here broadside array, what you would have done? Instead of 5m here 0 or 180, you could have taken it 90 degree or minus 90 degree. Okay, similar way. In case I have something like the maximum is in the direction of plus or minus 60 degree, what you have to do? Everything same. Here, instead of 5m equal to pi, whatever I had taken, please consider phi m equal to 60 degree. First, get the value of delta. That is the first thing to do always. Okay, get the value of delta, then do the same method. You are supposed to remember this equation. We have done it in the antenna array derivation, but please do remember, it will be helpful. So hope you understood this. Thank you. Practice more.